Hello everyone, welcome back to my channel. Today let's go over a medium question in the database category that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let me show you how I did it and let's go over it. This one is 3601, find drivers with improved fuel efficiency. So let's go ahead and the formatting is a little bit weird. Okay, that's fine. So basically, we want to find the drivers that in the first half and the second half of the year. There's a lot of information here, so let's just go step by step. The first half of the year and the second half of the year. So if you look at the month, that's what that's identified by. So let's first define the first and the second half. And we're going to say for the first half from January to June. So March, April, May, and June. And then the second half is just going to be 07 all the way to 12, 08, 09, 10, 11, 12. Okay, so now if you see in this, we're going to want the name, the driver ID to the name. So let's go ahead and just create that. And let's map key value. Okay, so we can retrieve it later through the driver ID, which is in the trips table because the driver name is not in the trips table. So IV and enumerate drivers, driver ID. So name of V equals to drivers, driver name of I. Cool. So now let's go ahead and so we defined the first and the second half. So for each driver ID, let's look at, let's make an entry for them in the first half dictionary and the second half dictionary. So let's call this first half and second half and make two default dicts of type list, because for each one we're just going to append this divided by this divided by this, and then do the average out of all of them. So for IT and enumerate trips, let's do the driver ID as the keys to these dictionaries. Enumerate trips driver ID. So it's important to know the trip date. So let's actually use the trip date. And let's call this cur date is string t dot split 0 just to get this part of the date. And then we want 5 to 7. That's the index range. So if we print cur d, we're going to ask if this is in the first half list or in the second half list. So if cur d is in first half, then first half of the driver ID, so driver ID of I, going to append the value, which is just going to be this divided by this. So trips distance km of I divided by trips fuel consumed of I. Cool. Otherwise, do the same thing. So sh of driver ID of I dot append trips distance km of I divided by the fuel consumed. So it says that right here for each trip is a fuel efficiency. So we want the average fuel efficiency for all of the trips for that driver in the particular year. So because we're comparing the first to the second half, so fuel consumed of I. Cool. So now let's get the first average and the second average. Let's create two dictionaries. And we're just going to go through both dictionaries. So for F and FH, we're going to set the key is going to be the same. This is still the driver ID, and that's just going to be the average, which is just the mean of FHF. Same here. So SA of S is mean of SHS. So let's print FA and SA. So those are the final averages. Let's see what's going on. Divided by trips fuel consumed of I. Huh, what's going on here? Drivers, driver ID of I. Raise key error. Yeah, but this is a default dict. Yeah, we're going to append this value. Yeah. Distance kilometer divided by the fuel consumed. I don't know why the compiler is not registering that. Okay, so FH is in the first half. Yep. Let's call this driver ID. DID. Why is this? Oh, from the trips. Sorry, trips driver. Got the wrong table. I don't know why they call that driver. Okay, cool. So now you can see for both dictionaries, let's say the first half year and then the second half year, you can see 11.9714. So that's just rounded. So what we're actually going to do as a workaround, because this is kind of a little bit messed up, the rounding in pandas. So the workaround I found was just 100 times this plus 0.5 divided by 100. And same thing here, 100 times plus 0.5 divided by 100. So that's going to offset things a little bit. So now you can see that 9.7 exactly matching up, 14.02, and then we can just say round this to 2 decimal places. Okay, so cool, awesome. So now we have what we need, and basically we want to go through all the keys in FA, and we have an answer, a list. So if F is also in the other dictionary, then we can just say, and also if SA of F is bigger than FA of F, then we can print F name of F, which is the reason for this, and then also the FAF, SAF, and then the difference, which we're going to calculate. Cool. So now the difference is going to be, the difference is just FA, or the second half's value minus the first half's value, and then diff. Okay, that is not, I guess we have to do this again, times this value plus 0.5 divided by 100, round this to 2 decimal places. 205, wait, what? Nope, that's not what I wanted to do. $205, no, this is like this. 2.05, okay. And then we round this to 2 decimal places. Okay, cool. So that seems to be correct. Now we can just go ahead and append these. So F, name of F, FAF, SAF, and difference. So mostly the challenges I faced with this question were through the rounding, but I was able to work around it. So let's go ahead and A, B, C, D, E, 5 columns. V and answer. Well, first of all, we have to sort it. So answer.sort by efficiency improvement. So P equals to lambda x, negative 1, because that's the difference, by in descending order, then the driver name, which is x of 1, in ascending order. Cool. So now we can say a.append v0, v1, v2, v3, v4, create a data frame. So of each sublist, you're just getting this one for this, this for this, and vice versa. setting all the columns equal to those lists. So driver ID equal to A, result. Let's get the driver name, first half average, second half average, just copying these. Efficiency, improvement, B, C, D, and E. And then let's just return this data frame. So let's run this. No, wrong answer. Jeez. Okay. Yeah, maybe rounding these is not the best idea. I knew something like this would happen. Cool. So, and also this, the reason to work around was that the built-in pandas library has like an issue, and now we have to do it manually, but that's okay because this is going to be a pain, but I'm going to still try to do it. So first of all, this is a string. So let's convert this into, let's say location is, we only have to do it for these. So location is string name f.index of this. We want 2. So we're just going to say +3 because Python's going to go up to not including that in the list slicing. And then we're just going to say name of f is equal to string name of f up to location, up to not including, really including up to 2 after. And then name of f is equal to a float name of f. Okay. What is going on? Index +3. Name of f. Oh, sorry. This is for fa of f. The third to the last columns. So these. fa. Okay. Okay, cool. So that takes care of that. We can just do for SAF, same process. SA of f dot index. And I'm sure there's a better way to do this, but this is my own solution. So SA of f is equal to string SAF. And then back to a float. We can even just say float. And then difference. Let's say diff is equal to string diff location, and then back to a float. Cool. So now these are going to be appended correctly, hopefully. So let's run this and submit it. And there you go, passes all test cases. So again, I'm super glad that I was able to come up with my own solution to this question without any help and solve it completely on my own. So that's it for this video. Thank you for watching and stay tuned for more.